The title, as Fatih said, is the Generalized Relative Pose and Scale Problem, View Graph Fusion of 2D-2D Correspondences. So, first of all, what does view graph fusion mean? And is the problem of merging two partial reconstructions that you can obtain from a structure from motion, for instance. Or it can be seen as the fusion of graphs, different graphs from different cameras, of camera views obtained where each of the graphs have where the graph views are registered. So this is a fundamental problem in geometry, and it has many applications. One of them is hierarchical structure from motion, where different seed graphs are fused together, and it serves as an initialization for a large scale structure from motion problem, which is quite relevant. The main problem here is that this suffers from the scale invariance, that is that each of these graphs, seed graphs, have a scale invariance problem. A different application is the log closure in a visual SLAM, and the idea is that instead of using single graphs, you may want to use a fuse of these different graphs. Again, the problem here is that each of these graphs have a scale, they suffer from a scale drift problem. So in short, view graph fusion can be seen as the problem of finding a relative pose and a scale between these two graphs, or can be seen as a similarity transformation problem. This is not new, and it has been mainly approached as a 3D registration problem, where you have a set of 3D points and you have another set of 3D points, and you try to find the alignment between these points. And this is generally named as generalized procrustes. It has been also approached as a 2D-3D registration problem, where you have 3D points and you have 2D measures, and you try to align these two sets of points. And this is called generalized absolute pose and scale. The main problem of these approaches is that they rely on 3D points, and this suffers from noise in the depth along the depth axis. So these guys, the main contribution of the paper is presenting directly a 2D registration process that aims at registering directly from the 2D measures. And they call the process generalized relative pose and scale problem. The advantages are directly somehow obvious. First of all, there's no dependency on the 3D points, so they don't suffer from this noise pattern, and it leads to an improved accuracy, as you can see, or you will see in the poster, in the several experiments that they have done. The poster number is 2C17. Thank you.